balance the redox reaction equation between sulfide ion and nitrate ion, producing ammonium ion and sulfate ion. Okay, so we have a full redox reaction equation to balance. And the way that we learn in our class is using a half reaction method. And first of all, of course, you need to think about what kind of condition we're in. And the problem didn't specify it. Unless the problem specify basic condition. In all other situations, we'll, by default, take it as the problem didn't say. Then we're in acidic condition. Alright, so once we establish that, let's get our half reactions going. SO3, 2 negative, would be turning into SO4, 2 negative. And let's balance that one first. Sulfur is already balanced. And then we need to look at oxygen. 3 oxygen on the left, 4 oxygen on the right. Make up the oxygen using water. 1 water molecule on the left side would balance the oxygen. And of course, if that happens, then we need to use H plus to balance hydrogen. And each water molecule have 2 hydrogens, so we need 2 H plus on the right side. Element-wise, we're balanced now. And before we move on to the next half reaction, we need to balance charge as well. -2 charge on the left side, 0 for water, -2, +2. So 0 charge on the right. That means we're going to need to use 2 electrons on the right side so that both sides would have 2 negative charges. So first half reaction done. Second half reaction, nitrate to ammonium. Alright, again, nitrogen is balanced. Good. Oxygen. We're missing 3 oxygen on the right side, so we're going to be putting in 3 water molecules. Balance hydrogen. A very common careless mistake here would be, oh, I put in 3 water molecules, and that means 6 hydrogen on the left side. If you do that, you'll be making a mistake because, well, look at ammonium. You already got 4 hydrogen there, and that need to be taken into consideration from the beginning. So instead of 6, you should have 10 hydrogen H plus ions put on the left side. Now you get the real balance of hydrogen. So oxygen, hydrogen balance, now charge. 10 positive charge, 1 negative charge, so +9 on the left. Only 1 positive charge on the right. So +9 and +1, 8 difference. Now, which side do we put the electrons? Well, for the 2 half reaction, the electron can't be on the same side. So your 8 electrons are guaranteed to be on the left side. Alright, so now we got both of the half reaction balanced. We need a full balanced redox reaction equation. And the priority for combining the 2 half reactions is that you got to make sure that your electrons cancel out. Right now it doesn't. 2 electrons can't cancel out 8. How do we do it? The easiest way would be, okay, if this process only produces 2 electrons, I'll make it happen 4 times. And that way I would get 8 electrons to offset the 8 electrons used in the other half reaction. And once you do that, add the 2 reactions, half reactions together, left side to left side, right side to right side. So 4 H2O, 4 sulfite, and remember the 4 applies to everybody in the first half reaction equation. Plus, let's see the second one, 10 H plus, nitrate, and 8 electrons. And then right side, 4 SO4, 2 negative, hydrogen, 8 electrons, ammonium, 3 water. Yeah. Okay, so this really should be our balanced redox reaction, but we do have some common sense on both sides. Electron is the first to cancel. The whole purpose of combining the two half reaction is to get rid of electrons. In your balanced redox reaction equation, you cannot have electrons. Alright, there's other things as well. 8 hydrogen H plus here, 10 H plus. So cancel your 8, and here you would have 2 H plus left. 3 water, 4 water. So cancel your 3, you would have just 1 water left. And there's nothing else. So rewrite the whole sign. H2O plus 4 SO3, 2 negative, plus 2 hydrogen plus nitrate, produce 4 SO4, 2 negative, and ammonium ion. And once we get this, we need to do an inventory count of everybody and make sure that we're getting the right sign. So left side, right side. Starting with sulfur. I got 4 sulfur on the left side and 4 sulfur on the right side. Hydrogen. 2 hydrogen, 2 hydrogen, so 4 hydrogen on the left side and H4. 4 hydrogen on the right side. Oxygen. 1, 3 times 4, that's 12, so 13, and 3 more, 16 oxygen. 4 times 4, 16 oxygen. Nitrogen, 1 on the left, 1 on the right. And lastly, don't forget, we also need to inventory our charges. Left side, I got 4 sulfite, which is -2, so -8, plus 2 positive of hydrogen ion, so -6, and 1 nitrate, -7. And on the right side, we got 4 sulfate, that's total of -8. And then we got 1 ammonia, so +1, and -8, -7 as well. Everybody checks out, and that means we got a good balanced redox equation. 1 water, 4 sulfite, 2 H plus nitrate produces 4 sulfate and 1 ammonia. And that is the balanced redox equation that we needed. So along the way, we balanced our half reaction. We manipulated one of them to make sure that our electrons cancel out, and we canceled some common ions, molecules, and electrons when we combine the two half reactions. And our inventory check confirmed that our balancing was successful.